Okay, this is 6.9 radian measure. This is our second to last section for circles. This is kind of a tough one, so make sure you pay attention. So radian, what is a radian? It sounds like radius, so it is related to that. Okay, so what a radian is, it's the ratio of an arc length to the radius of a circle. So for instance, this arc length right here, okay, whatever that length is, it's the same exact length as the radius, okay, right here. So that length and the length of the radius are identical. So in this case right here, it looks like if we were to relate it to the graph that it's drawn on, it's got 1, 2, 3, 4, 5. So this is 6 units. Well, that length right there of that arc is also 6 units, okay? The exact same length. So that's what you call a measure of 1 radian, okay? That's how the ratio goes. It's like kind of like different units. So like if you were to talk about 1 mile, well, we can represent 1 mile in a different units. It could be feet, 5,280 feet. See, so this right here is represented as 1 radian, okay? And it can also be represented as a certain amount of degrees, all right? So let's look more into it. Let's look at this next statement right here. So if we have a central angle that intercepts an arc that has the same length as the radius of the circle, the measure of this angle is defined to be 1 radian. So this angle right here, okay, which is also the same as its intercepted arc, that right there is 1 radian. Okay, as it's written there, it's kind of hard to write right here. That's messy. I'm just going to erase that. Okay, but that length of that measure of that angle is 1 radian, which you know it to be written as in degrees. All right. And then another way to look at how this ratio works is think of the degrees. So if we have 360 degrees, which makes a full circle rotation, so we don't really say it's an angle, it's just a full rotation, but it can be considered an angle, then that measures 2 pi radians, okay? And so here's how I want to show that to you, 2 pi radians, which 2 pi is about 2 times 2.14 is about 6.28, right? Okay, so about 6.28 is roughly 2 pi. So I want you to look at this right here. So that's 1 radius, right? Here's another radius. There's another radius. Here's another radius. Here's another radius. And there's another radius. So how many is that? 1, 2, 3, 4, 5, 6, and then a little bit more. So you can see that is about 6.28 radians, okay? But we don't really say it in decimal form, we'll say it in terms of pi, okay? And if it's related to circumference, because what's the circumference of a full circle? The formula at least, 2 pi r, okay? Let's look at 180 degrees right there. 180 degrees, which makes a semicircle rotation, so that's halfway around the circle, that measures pi radians, which remember, that's half of 2 pi radians, which what's the rough estimate of pi? About 3.14, right? So if we look at that right there, we have well, let me get rid of these right here and just focus on these right here. So we have 1, 2, 3, and then there's that little remaining space left over right there, which represents the 0.14. So there's 3.14 radians in a semicircle, which is 180 degrees. So you can see these are 2 different units. We have degrees and we have radians. So what we're really focusing on today is how to translate to radians, okay? And whenever we represent radians, we usually say it in terms of pi, okay? Not all the time, but most of the time it's in terms of pi. So let's talk about, since we're going to be dealing with angles, okay? You know a little bit about angles. So an angle is a shape formed by two rays that come together. In trigonometry, one of the sides, okay, of the angles is called the initial side. And then the other side that is rotating away from the initial side is called the terminal side. So I have a representation right here of this angle. Let me get my highlighter. So this right here is your initial side, and then you see how it's rotating. That's the amount of rotation this way. This will be your terminal side, okay? And so we're going to draw some angles up using a radian measure. So here's how we draw out our angles. So it says we usually draw our angles on a coordinate axis with the positive x-axis being the initial side. So I have that highlighted in red right there, okay? So that's the first part of our angle, okay? That's always going to be your initial side, okay? And so then if we're going to go in an angle that's going to rotate in the counterclockwise direction, that is positive. So if I'm going to make an angle that is headed in that direction, that rotation right there, then this angle right here would be a positive angle. Now, if I'm going to go in the other direction, the clockwise direction, then that's going to be what we have as a negative angle. Okay, so there are negative angles here. So if I go this, again, this is always my initial side. So if I start rotating this direction right here, this would be a negative angle. Okay, so let's practice drawing some angles. So what would a 210-degree angle look like? So let me get my pen. So we're going to first start off with the initial side right here. And so 210, so look, this is 90, of course. You know what a 90-degree angle is. And then this is 180. And then this is all the way to 270. So we're not going all the way to there. So I would say about right there is 210. And this, it can just be an estimate. We don't have to get the protractor out, okay? So a 210-degree angle is that red rotation right there, okay? That's a 210-degree angle. If we want to do a negative 150-degree angle, then we're going to go in the other direction. We're going to go that direction over here. So that's going to be up to 90. And then 150, okay, think 90 subtract from 150 is 60 degrees, which ends up right there where we drew our other angle, okay? So that is the same one. That angle right there, look, is the exact same measure as for each one. 210 and negative 150 looks exactly the same when we draw it. So I'm going to erase this and I'll show you a little bit neater one right here. Okay, so you can see that there's your 210-degree angle and there's your negative 150-degree angle, okay, which is kind of the way I had sketched it a second ago. So just to give you a little bit more terminology, whenever that happens, whenever two angles terminate in the same place, we call those coterminal angles, okay? And there's an infinite number of ways to draw an angle on a coordinate axis. You just have to add or subtract 360. So remember, we can go around and around and around as many times. So this angle could be 360 plus another 90. What's 360 plus 90? 450. Okay, so you know it'll look like a swirl, but the way you would draw it, it would just be there's your initial side, there's your terminal side. Okay, so that could be represented as a 90-degree angle. It could also be represented as a, what did we just say, 360 plus 90, 450-degree angle. And you could add another 360 and keep going and going. So that's why they're saying there's infinitely many angles. Okay, just to kind of see what it looks like with radian measures. Remember, here's the initial side. So 0 right here. If I rotate 90 degrees, okay, that would be pi over 2. Okay, because remember, we just said a second ago that a semicircle was pi. So what's half of pi? Pi over 2. And then we said a full circle rotation or a full angle, full rotation is 2 pi. So going all the way back to the beginning is 2 pi. So over here, if that's pi, then this is 3 pi over 2, which is kind of 1.5 pi. Okay, so that's just taking a quick look at radian measure. So here's quadrant 1, here's quadrant 2, here's quadrant 3, and here's quadrant 4. Those are the different sections that the angle can lie, okay? All right, how do we convert radians to degrees? It's pretty simple. It's just one simple multiplication. So if we're going to convert from degrees to radians, meaning we have 90 degrees and we want to make it into a radian measure, all we're going to do is multiply that by pi over 180. And then if we want to convert a radian measure to degrees, all we're going to do is multiply by the opposite of that, 180 over pi. And lastly, the other formula we're going to use whenever we want to solve for an arc length, okay, and we are working with radian measure, okay. Now you can always convert to degrees because you know how to solve for an arc length. You're going to do the radius and times it by the radian measure, okay. The other formula that you know, I'll write it down real quick, is x degrees over 360 degrees times 2 pi r, okay, which is circumference. So this is the formula that you know for arc length. But if we don't have it in degrees and we have it in radian measure, then we want to use that formula right there. Okay, so we're going to use these three formulas to do some problems now. So first example, it says a central angle of a circle has a measure of 1 radian. If the radius measures 6 centimeters, what's the measure of the intercepted arc in degrees, and what is the length of the arc? So that's kind of the picture that we were working with earlier. So I'm going to draw it real quick. Remember we had the radius right here of the circle, and it went to about right there, and we had said that that was 1 radian, okay? So that's just a sketch right there. So how do we turn 1 radian into degrees? So let me go back and refresh your memory. So to go from degrees to radians, we're going to multiply by pi over 180, okay? Well, we don't know the degrees, that's what we're looking for. So we're going to use this formula here where we're going to multiply by 180 over pi, okay? So 1 radian times pi over 180 degrees, which that's simple. It's just pi over 180, okay? Or did I do that backwards? $180 over pi. I did it backwards. Of course I did. So let me go back and change that. And then that equals 180 over pi, okay? So what is 180 over pi? Well, we want to go ahead and divide that out. So let me get my calculator because we want to turn it into degrees. We usually don't list that in terms of pi. So 180 divided by pi, that is about 57.3 degrees. Okay, so 57.3 degrees. And so when you look at that, okay, that looks about right, okay? So that's 57.3 degrees. So now it's saying, though, what is the arc length? Okay, so what is the length? And so this is in centimeters. So we're going to have to use this right here because the radius is 6 centimeters. So let me go back to the formula, and I'm going to show you which formula to use. We're going to practice using this one right here. Arc length equals the radius times theta, okay? theta is whatever the angle is in radians. And so this is going to be real simple. So 6 times 1, because it's 1 radian, that's what theta is. Okay, that's going to equal the arc length. Well, what's 6 times 1? 6. So the arc length, and again, you didn't even really have to do that because we just talked about how if the radius is 6 centimeters, and if this is going to be 1 radian, then that means that length is also 6 centimeters. That's what we had talked about. The radius is the same as that arc length. So using that formula, I mean, it's super simple, just multiplying by 1. Okay, let's look at these down here. It says, what is the degree measure of each angle expressed in radians? Or what is the radian measure of each angle expressed in degrees? So it depends on what they give us. And then it says, draw the angle of each measure. So on this first one, we have pi over 2 radians. So pi over 2 radians. Okay, so pi is over 2 times, to turn it into degrees, we are going to multiply by 180 over pi. Okay, so now you'll notice if there's a pi on top and on bottom, those are going to cancel out. So it's really just 180 over 2, which is 90 degrees. So pi over 2 radians is 90 degrees. So here's how you draw the angle. The angle, remember, the initial side always has to go on the x-axis, okay? And then 90 degrees in the positive direction has to go up or towards this direction. So there's the angle right there. Let's go to number 3. Number 3, we have it in degrees, but we want to turn it into radian measure. So we're going to multiply it by pi over 180 degrees. Okay, and so when we do that, we want to simplify this number right here. So we have 225 over 180 times pi. This fraction needs to be simplified. And so how does that simplify? Let's see what goes into that. 225 divided by, see, 45, I believe, goes into both of those evenly. So 225 divided by 45 degrees is 5. And then 180 divided by 45 is 4. So this is the radian measure of 225 degrees, 5 pi over 4, okay, or 5 over 4 pi. Let's go try the next one over here. Oh, and we have to draw the angle, okay? So the angle that we're going to draw for this one, remember the initial side is always going to go that direction. This is a positive angle. So that's 90, 180, 270. So it's going to be about right there. So that angle, I probably would fix it a little bit better than that because that looks too close to 180. So I'm going to say more so like that. Okay, so right there from there to there, that's a 225-degree angle. Okay, we always go start to the right. Okay, let's try the next one, 2 radians. So we're going to turn that into degrees. So we're going to do 2 times 180 over pi. 2 times 180 over pi, which ends up being 360 over pi. Okay, and we have to put that in our calculator. 360 divided by pi. So that's about 114.6 degrees. So 114.6 degrees. So now to draw the angle, remember here's our initial side. 90 is going to go straight up, so about 114 would be about like that. So that's a 114-degree angle. Okay, another positive angle. All right, last one. Let's turn our last one to radian measure. So we're going to take negative 150 degrees and we're going to times it by pi over 180. Okay, so that's about negative 150 over 180 pi, which this is going to reduce. 3 goes into that. This is going to be negative 5 pi over 6. Okay, so this is the radian measure. Okay, and we don't ever have to write out the units, but usually we can shorten it and say rad, but that represents radians. So what does the angle look like? Because we have to draw the angle measure. Okay, 150. I like to use the degrees because I'm better at visualizing the degrees as opposed to the angle, as opposed to the radian measure. So remember, we always start this way. Now, remember, a negative angle needs to go in this direction down here. So it's going to rotate here. So that's 90 and that's 180. So probably like this. So from there to there, that's your negative 150-degree angle. Okay. All right, let's try 3 more examples using the arc length. Okay, so from here to here, it says the length of that red arc is 20 pi over 3 inches. And it says find the radian measure, okay, of that angle right there in radians. So I'm going to go back and refresh your memory of what formula to use. We're going to use this formula right here. Arc length equals radius times theta. Theta is just a Greek letter. So, I mean, that represents the degrees in radians. So it's like saying x, okay? It's just the letter. So let me write it down. The length equals radius times theta, okay? Well, I have the length, so I'm going to plug that in there. 20 pi over 3 equals, I know the radius, and so this is what I'm looking for, theta, right? So what I'm going to do here is I'm going to multiply by 1/5, okay, or divide by 5 to get rid of that. Okay, that's the same thing as multiplying by 1/5. Okay, so what we get here is 20 over 15 pi equals theta. Okay, but you can't leave it like that, so you need to reduce it. So that reduces as 5 goes into that 4 and 3, so 4/3 pi. That is radians, of course. That is the measure of that angle right there. Okay, and if I had asked for it degrees, all you would do is you would multiply 4/3 pi times 180 over pi. So let's just see what that would be in degrees. Pi's cancel. I know 3 goes into 180 60 times. 4 times 60 is 240 degrees. So that measure right there is 240 degrees, or 4 pi over 3 radians. Okay, let's try this next one. It says find the length of the indicated arc. See, so now we're going to find the length of this. So remember, our formula is length equals radius times theta. Okay, because this right here is radian measure, so that's the formula we want to use. So we're going to plug in 5 for here. Theta is 2 pi over 3. And so the length is going to be 10 pi over 3 meters. Okay, 10 pi over 3 meters. Now, if we wanted to give the actual decimal, so I'm going to put that in my calculator. 10 times pi divided by 3. So that is roughly 10.47 meters. That is the length of arc C. Okay, and again, you can leave it in terms of pi, or you can give me the decimal answer too. So either one of those is correct. Okay, last one for the day. Find the measure of this arc C right here. Okay, not measure, the length. Okay, the arc length. So our formula is length equals radius times theta. Okay, well, this one's tricky because they give us the measure in radians over here, but I need to know this one right here in order to find this length. Okay, so what is that in radian measure? So if you go back to our notes, let me go back to right here. Okay, right here, 360 degrees is 2 pi radians. So a full circle is 2 pi radians. Okay, so I want to use that to get this right here. So if the whole thing is 2 pi radians, what I can do is I can take 2 pi, subtract 6 pi over 5 from that. Okay, so that's kind of difficult with the fraction. So what I need to do is I need to turn that 2 into a fraction with 5 as its denominator. So that would be 10 over 5. So 10 over 5 pi minus 6 over 5 pi is 4 pi over 5. So that is the measure in radians of 4/5 pi. Okay. And the other way to look at it too is 4/5 plus 6/5 is 10 over 5, which is 2 pi. Okay, so some of y'all might be able to do that in your head. All right, so that's what I needed to use to get the length. So my radius is 15 meters. Theta is 4 pi over 5. So let's reduce that. That goes into it 3 times. So 12 pi meters is the length of that arc C. If I want to turn it into a decimal to see what it would look like as a decimal, I just need to multiply 12 times pi, and that's about 37.7 meters. So again, either one of those, you can leave it in terms of pi if you want. If you want to put it in decimal, that's fine. If the instructions say otherwise, you need to follow the instructions. Okay, and then that is radian measure.